a supermarket, or we can say I'm going to a bookstore, picking up a product, it finds out what product it is, the computer vision algorithms. In this case, it finds what is the Amazon rating of this particular book, and project on top of that book itself. Or you can find, what are my friends have to say about this book, the reviews of my friends.
In 1943, Churchill gave a famous talk.
Of course, you can augment with sound. The New York Times has a review of this particular book.
Thank you, MIT.
This was Obama's visit to MIT, and I can see the live of what is going on inside. I cannot go inside. There's a security issues. In this particular example, the weather map which was printed, it was estimation, but now you can have the live dynamic information. So we like digital world because digital world has something different than the static world. The information can change, and if we can get that outside the digital domain, you can do lots of things. You can check your, what is my flight has been delayed. You can augment people, right? So it is getting the Facebook cloud from my friends list and then finding what he's up to right now. This is Boston Red Line, and I'm playing Pong game on the ground with my friends. And of course, you can do lots of other things. And there are lots of applications coming up in the next version after that we have seen this video. What we did in this particular example, I removed the microphone from that particular camera and made a clip out of that. So now you can pinch that clip to any piece of blank paper and start using that piece of paper as a computing interface or as a tablet computer. So now my camera is tracking my hand movement, the projector is projecting information, and the sound of touch is getting as a touch data.
I am a wilderness explorer in Tribe 54.
You can play games, right? In this one, there is no hardware sensor inside the paper. The camera is acting as a tilt sensor, how I'm holding my page or something like that. So the idea over here is that you can of course do all sort of normal computing, go back to your browsing and looking into your emails and stuff, but you can do something more exciting than the normal computing world has given you. Here you can see that I'm taking that information as a physical information source. I mean, I'm moving between the two worlds. Like now I want to work on a big size computer because typing is much better on a full size keyboard, right? Or you can do document editing in a traditional way. You can cut paste. In the old days, people used to do that on a newspaper, like printed something from here, printed something from here, make a document and say, okay, this is the final version. Or maybe I want to make some little bit changes over there, so let's change this value a little bit. And now print this one, right? So after this particular video, we have so many new applications coming up, and there are lots of things that we have done, but we haven't have a video for this one, the demo video. But let me show you some of the pictures that some of the sponsors I'm working with. So you can augment anything, like you can use the word of gaming, education. It's already your third coffee, don't drink much. So the applications of this particular approach is enormous, because when you are thinking of joining the digital world with the physical world, you can do lots of things. That is my personal thought. So I'm showing you a couple of the ones. Some of them you've seen. When I was in Japan, this was useful for me because it can tell me that, oh, is it vegetarian or not, right? That's good for me at least. We are also right now interested in how can we have augmented reality but not in the normal sense. So in this particular example, we are building augmented reality in a remote augmented reality. So a person who is novice, you can guide someone how to drive an airplane or something like that. Someone else can augment someone else's digital world. So there are lots of applications coming, and in this example, we are augmenting using sound. People cannot speak. So then it gives them a sound rather than giving so the person can do the sign language and the system will make the sentences for him and the system will speak on behalf of him. So we can do lots of stuff. One point I want to point it out over here, that in normal interfaces, normal computing devices, the limitation is the human limitation. It's not that we cannot make iPhone this small, but we cannot use it, right? But in this approach, the device can go as small as invisible. So this is one example of that. And the next big change that we are doing is we are replacing the camera with the depth sensing cameras in the next version, where you don't need to wear any color markers in your hand. You have bare hand and you can still have the gestures and whatever you've seen in earlier video. So as a last thought, I would like to leave, and I want to go in that thing, that the world that we have created is the product of our thinking. It cannot be changed without changing our thinking, right? So that is what I always keep this as my thought, and I will leave with this idea. Thanks a lot.
Thank you, Pranav. That's fascinating. I can't wait to get mine. So our second speaker, Natan Linder, is also a part of the Fluid Interfaces group at the MIT Media Lab. Very interesting background, Sun Microsystems, actually a co-founder of Samsung Electronics, Israel's R&D center, a lead UI designer at Heartland Robotics, and I also just learned today an Intel fellow. And my interactions with Natan have been very interesting over the last couple of weeks in that he has a truly creative perspective on how he looks at the world around him. And his focus is on fusing design and engineering to create novel human experiences. And he's going to talk to us a little bit about a project called Luminar. So please welcome to our stage, Natan Linder.
So, good morning again, everybody. And my talk is going to be about adding I/O to the real world and the new form factor we're going to use to do that. So, to begin, it's always great to follow Pranav because he does such a great job explaining the problems in our space and how we actually need to connect the digital and the physical world. So on the screen here you see the picture of Patti Maas, Professor Patti Maas at the Media Lab, our advisor, and her desk is a really good example of how complex is the real world. So we work with multiple devices, notes and documents, papers, and it's our job to combine them. And being human, we have a very narrow pipe to actually accomplish that. We are responsible for that connection, and it's a hard job. So in fact, we have adapted to our interfaces and not vice versa. And another way to look at the same problem is that we all have become curators of devices. It's almost as if we babysit them. We charge them and we carry all the cables and update the software, and we take care of all the information that needs to go through between them. And so they're definitely part of our environment, but they're not embedded in it. So what we do in our lab is we try to think out of the box and come up with radical yet relevant form factors to solve this problem. And when I was starting to think about this, my thoughts were, wouldn't it be great if anywhere we had a power socket and wireless communication where we just have a natural interface to the web? And then what if that interface could look like this, a very familiar object that never left us since it was invented? And then earlier this year, I started working on the Luminar project. Just to tell you a little bit about the name, it's a play on the word luminaire, which is a single unit of lighting, and then we just changed the end, and we add augmented reality to it, and you get Luminar, which is a robotic lamp that is capable of augmenting the world around it. Now, this is not an entirely new concept. It was introduced about 10 years ago by one of my predecessors in the lab, John Underkoffler. But it's only now that we're able to actually implement it. So I want to show you a quick video of the prototype.